Good morning, students. Today we will move forward with the third chapter of Strategic Cost Management and Performance Evaluation of the CA Final Syllabus, Paper 5. We will be doing Chapter 3, which is titled as Lean System and Innovation. This chapter basically has an overview given. Reference is being made to the Jan 2019 edition of the study material. We have an overview being given on page 2. You may be able to see it in your study material. A chart which depicts various different concepts that would be dealt with in this topic. Now, before we move on, let me clarify to you. Similar to what we adopted as an approach in chapter 2, we intend to cover this chapter also in two sessions. Session 1, which will deal with the first half, and session 2, which will deal with the second half, and bring it to closure. Today we will have to look at the first half approximately till page 24, if possible. The various concepts that are being depicted in the overview chart are something like a lean system, which includes subcomponents: just-in-time, Kaizen costing, the 5S. We do not know whether we will be able to cover from the total productive maintenance and onwards, which includes cellular manufacturing, Six Sigma, process innovation, and business process re-engineering. Possibly we might do it tomorrow. All of these put together are termed as lean system and innovation. Now, what exactly is a lean system? The term lean itself, in plain English, we are able to understand from a human body perspective. It avoids excess fat, or rather trying not to be obese. Now, when a person tends to be obese or excessively fat, then we are able to quickly make out that such people would lack the flexibility required, would probably take more time to do certain things, and therefore might result in wastage of time. Whereas one who is lean is able to be more flexible and is able to discharge his work or her work in a more efficient manner. In other words, there would be lesser wastage when a person probably tends to be lean, unless he or she deliberately intends to behave otherwise. Now, using this, if you look at the study material, lean system is defined as an organized method for waste minimization without compromising on productivity within a manufacturing system. In other words, it emphasizes the importance of optimizing workflow through strategic operational procedures while minimizing waste and also being adaptable. Fairly self-explanatory. Now, in a particular manufacturing process from end to end, if any type of wastage is spotted, that is basically categorized as a non-value adding step. Therefore, the fundamental objective behind the value chain analysis itself was to identify such kind of non-value adding services so that what remains after the elimination of such non-value adding activities would be purely value adding activities. And why do we want only value adding activities to remain? Because that is what forms the primary basis to add value, to add the satisfaction level to the customer. Now, when we talk about waste, waste is being analyzed into different types, typically 7 of them. One relates to overproduction, probably producing something much ahead of a demand. The second one is automatically linked to the first one, inventory. Hence, automatically what would happen is you would tend to maintain an inventory level which is far above what would be minimally required. For example, you need to meet your daily expenses only 100 rupees as a pocket money, but your dad gives you maybe 2000 rupees and you have it and roam around. So there is always a risk of carrying extra. which will involve cost. For example, if a burglar was to steal, could steal the entire 2000 instead of just 100 rupees. So there are some additional risks while it has certain advantages as well. Waiting. In a particular manufacturing activity which involves 10 steps in it, waiting basically indicates that it could result in a type of wastage, in the sense products are being made to wait in the next production step. For example, as we had learned that there is this bottleneck and non-bottleneck related machines. If the non-bottleneck machine is being made to function at 100% efficiency, and the bottleneck machine works at less than 100%, then what we noticed was there will be unnecessary piling up of inventory, which is again a wastage. Motion. This refers to irrelevant movement of people within the manufacturing process, meaning unnecessarily people walking around. Now, we have probably studied in our CA intermediate a brief concept, a brief segment on time and motion study, which basically is all about identifying the various steps involved in executing a particular activity and trying to find out what are all those activities which are relevant and irrelevant, remove the irrelevant ones. Then we move on to transportation. In a manufacturing setup, probably the items that are being manufactured until they are converted into finished goods might be required to be shifted from one assembly line to another assembly line to another assembly line, and so on and so forth, which could be uh, which could be a few meters away or so. This could probably also involve unnecessarily incurring expenditure on extra materials handling, which probably we want to avoid. Rework from defects, which is basically not arriving at the perfect solution at the very first time. Now, there is also another aspect, which is over processing, which is probably like in mathematics, we have a problem to be solved. Instead of finishing the solution in just 5 required steps, you would probably take 8 steps to solve the problem, 3 of them remaining typically certain steps which have no value to the solution. Now, when we look at actually this lean system, it involves certain types of techniques to implement this lean system. A few features mentioned there, for example, the just-in-time, the Kaizen costing, the 5S, total productive maintenance, cellular manufacturing or one-piece flow production systems, 6 Sigma. Now we will be covering individually each of them over this and the next session. Now, these applications that are there, which help us implement a lean system, are based on certain principles, underlying principles or tenets. One, the objective obviously will be to ensure that quality is delivered perfectly the very first time. It results in minimization of wastage, any form of wastage from end to end. And continuously the entity is working towards process improvements, quality improvements, and also being flexible, being adaptable to the situation on demand. Now, the next one deals with the characteristics of lean manufacturing. What would be the traits of a lean manufacturing system installed by an organization? One, there would be no waiting time. Waiting time will be completely reduced between processes, between steps in a particular process. Two, there would be zero inventory, therefore no inventory carrying cost, and probably even obsolescence can be minimized. Pull processing. Earlier, we had learned in supply chain management that there is this upstream, traditional supply chain management, and I would call something as a modern supply chain management. And I had indicated to you, traditional supply chain management is more a push model wherein you manufacture in anticipation of demand. Whereas in the modern supply chain management, it is a pull model where the actual demand is what triggers the production. Now here again we find pull processing, Just in time also adopts this, or these techniques adopt pull processing model, meaning unnecessarily avoid carrying extra inventory and incurring unnecessary costs. Continuous flow of production, which is what minimizes the waiting time, etc. Continuously finding ways of reducing the process time in terms of improving the quality constantly. Now, with all these in mind, let us launch ourselves into just in time. Now, let us look at the concept of just in time. What does it refer to? It is nothing but a collection of ideas that streamline or rectify a company's production process activities to such an extent that wastage of all kinds of time, material, and labor is driven out of the process. So it has a huge impact, a positive impact on the cost of the company. Now, there are some definitions given for just in time with regard to what is just in time by SEMA. What is just in time production, which means production system which is driven by demand for finished goods, whereby each component in a production line is produced only when needed for the next stage, thereby avoiding the waiting time in the process. And just-in-time purchasing means purchasing system in which material purchases are contracted such that the receipt of material and the usage of material to the maximum possible extent coincide. Therefore, you do not unnecessarily stack up raw materials and have carrying cost, probably loss of obsolescence, etc. Now, there are several steps involved in this just in time, but before we get into this just in time, which means that the connectivity must be perfect, there should not be any unnecessary loss of time waiting for things to happen. Probably things could be better utilized rather than wasting time. Now, let me just narrate a real life incident that happened in my life, purely from the viewpoint of highlighting the significance of just in time. In the month of February, as a family, we had to make a trip to Rameswaram. So myself and my son had actually reached the Egmore railway station much ahead of time. Our train was supposed to depart at about 7:15. We were there hopefully by about 6:30 or so. There were three other family members who were supposed to come from another place to it, and they were to join us. Now, they virtually came at about 7:12 or 7:13 when the train was supposed to depart at 7:15, or probably they entered at about 7:14. And I had virtually made up my mind that I said to my son, we will have to cancel this trip. When the train reaches sanatorium, we will get out and move on to our residence. That very last minute, our three family members entered in a very, very filmy style. Literally, it was as though a film production was going on. I was standing at the doorstep of the compartment, trying to spot where they are coming from to run around and get the luggage. They were literally screaming and running. And when they entered, within a minute, I guess the train started departing. Now, the point is, when I asked one of them, is this how you plan and come to the railway station when you have to depart? The train departs at 7:15. I was told by my own family member that, well, you have a concept called just in time, which basically implies we should not waste time. And therefore, we decided that we will not waste time in the platform unnecessarily waiting for the train to depart. So we have actually ensured that we reach just a minute before the departure of the train. Now, jokes apart, just imagine my heartbeat in the railway station. How would I have felt? Though the point is correct, this is what exactly is just in time. Things happen just at the last minute. But one thing is very, very critical. You must be sure that it will certainly happen. It can't be that you will come at 7:16 and miss the train. This should never happen in just in time. So fundamentally what I was told was correct. But in India, probably keeping up the time could probably be an issue in terms of various external factors affecting us. For example, in Japan, a bus is supposed to depart at 3 o'clock and pick you up at 3:05 or 3:06. Exactly 3:06 it reaches your bus stop. Would something similar to that ever happen here till now? It's a far-fetched thought. Okay, moving on from there, we see with regard to just-in-time, there are some boxes that are being presented in the just-in-time concept on page 5. Several things. For example, uh, after those boxes, let me begin with the explanation. One of them, the very first one says spare parts or materials from suppliers must be transported on the exact date, at the exact time when they are needed. As I said to you, if you intend to manufacture your product at 8-9 a.m., the materials will reach you probably just a minute or two before 8-9. It's for sure it will reach you. The next one, straight delivery to the production flow, which means what? The materials will not be delivered to the storekeeper in the stores where it will be maintained, you'll incur inventory costs, etc. It will be delivered to you directly in the production assembly line, meaning receipt and usage will be coincided as much as possible. Third, in the traditional system, we would want to inspect the raw materials which are brought into our premises to ensure they are of the appropriate quality, and that takes time. Here, what we try to do is our engineering staff will not do the inspection here. They go to the supplier's premises, and there itself they will conduct it much ahead of time and try and ensure that whatever stands manufactured through their processing would indeed be of the top quality. So it helps us from undertaking preventive related inspection rather than curative related inspection, which is once the materials arrive and then you try to inspect. So out of 10,000 raw materials that arrive, you can't inspect the entire 10,000. You would only inspect probably maybe 100 and try to decide upon the entire 10,000. Whereas in the supplier's plant, in the manufacturing part line itself, prior to manufacture, you will try to, our engineering staff will try to investigate and help the supplier prevent or avoid any problems, any defects in the manufacturing line. And then once we have, now that we are clear about the funda of just-in-time, we need to appreciate that when we select suppliers, source suppliers, we must ensure that we choose such kind of suppliers and approve them who will be able to deliver the product at the right time in the right quantity and of the right quality. If that is not going to happen, then there is no point in trying to go ahead with them. Therefore, and this must happen on an ongoing basis, continual basis. Therefore, as and when the stock starts depleting, meaning the consumption is happening at the consumer side, maybe let us say a departmental store, a supermarket, the products are leaving the departmental store or the supermarket because customers purchase them. Immediately the information must be relayed to us, and which will be relayed in turn by us to our supplier so that they know that the stock has started depleting with the retailers. We must start manufacturing immediately. Now, when this kind of a relay of information must happen, you can't have a non-electronic mode for that. An electronic mode is much advisable, taking advantage of the current innovations in technology. This is what happens through EDI system, which is electronic data interchange system between two different parties to communicate such depletion in stock levels on a very quick basis, which is also driven by the pull model. Then dropping off products at the specific machines in your production line, the raw materials that are being brought by the suppliers, by the transporters, in fact might probably be delivered at the appropriate machine which is to process that particular raw material. To that extent, you will be minutely managing in just-in-time. Shorten the setup time. And this concept is something which is very interesting. In the traditional days, we used to notice that huge machinery used to be installed in plants which involve a very high level of capital expenditure. But to justify that capital expenditure, the machines will have, the management probably will prefer to operate these machines from a manufacturing perspective in terms of keeping the downtime as little as possible. What I mean is, since a huge amount of capital expenditure is involved, the entity would try to maximize production out of that particular machine. Therefore, the concentration in the traditional days was only to maximize the output rather than actually concentrate on maximizing the quality of output. Now, when we intend to produce more quantitatively, we also must bear in mind a machine probably could be used for producing 2-3 different types of products, and therefore it might require a setup to be done. Sometimes a machine might be required to process 1,000 numbers in a batch, sometimes 2,000 numbers in a batch, sometimes 5,000 numbers in a batch. That also requires a different setup, as you have learnt in batch costing in your CA intermediate syllabus. Now, such kind of setup activity involves a basic element of cost. Now, when the machines are extremely sophisticated, it takes quite some time to actually set up the machine. Now, the cost of setup could be quite large. The fundamental objective itself in costing is to minimize the cost. How would one want to minimize the cost? When the batch setup time is high and therefore the batch setup cost is high, the way we can minimize the cost is try and run the batch for a long period of time, so that instead of manufacturing just 2,000 items in a batch, if you could try and manufacture 3,000 items in the batch fixed cost of 1,000 rupees, for example, gets apportioned over not 2,000 units but over 3,000 units, meaning the average fixed batch setup cost will tend to be lesser and lesser when the size of the batch increases. Now, we are able to understand here that in the traditional days, since the setup used to take a lot of time, the cost is high, and therefore long batch runs were required. But then in just in time, we have read one characteristic: we must be adaptable, meaning the machines are such that they are probably a little smaller than what they were in the past. They can be easily set up. Therefore, since the machines can be easily reconfigured or set up, the batch setup time would drop significantly. Therefore, the batch setup cost will drop significantly, and therefore there is no necessity for a batch to be operated on a long run basis, meaning customer orders are for small sizes as well. You can be adaptable to that and deliver to them on demand. That's the advantage of shortening the setup time. Then comes the eliminating the need for long production runs, which I've explained to you now. Now, all these things we must appreciate will automatically kick off the process whereby employees of the organization will have to be trained in a completely different way compared to how they were trained in the traditional days. They will have to be trained now to operate different types of machines to be operated. Now, why is this required? We have also seen a little above that one of the techniques used apart from just-in-time is cellular manufacturing. When we come to that concept, we will understand this a little better, though it will be touched upon even in just-in-time. Because in just-in-time, what happens is machines, rather different types of machines which are required to produce a particular product will all be kept close to each other and will be operated by one particular operator. Therefore, gone are the days when one operator used to be assigned only to one particular machine, which meant that he or she needed to know only how to operate that particular machine. But then in JIT environment, the operator is left to handle 5 or 6 different types of machines that are required to complete the manufacturing of the product. Therefore, he must know how to operate each different type of machine. The advantage is his job becomes more interesting. He feels more happy to work with a variegated environment rather than an extremely monotonous environment. Now, several alterations in the supporting accounting systems is a very, very key point, which I will touch a little later. Now, the aspects that I have explained will help you understand the following paragraphs. Now, we have seen that, as I've explained, that in the traditional days, the batch setup time probably used to be very long, and therefore management used to avoid short batches. They used to entertain long batches. And when long batch runs are being done, and if the defect has not been identified quickly, then naturally there will be a huge inventory that will be built up, involving inventory cost as well as high inventory carrying cost. Apart from that, and obsolescence loss as well. Apart from that, when the defects have not been identified on a timely basis in the traditional days, the number of defects that are defective products that are being manufactured could also be very high, meaning that uh, the so-called non-conformance cost can also tend to be very high. Post identification, one might have to spend a lot of money to rectify those defects or scrapped items. Now, how can we resolve this particular problem? There are two kind of concepts that have been suggested to tackle this issue. One is your CAN bank card, KANBAN, CAN bank card. Now, what is all about this CAN bank card? While you read the para, it's a very, very simple thing which we've already understood. It is nothing but the modern day supply chain management, implying pull model. Pull model, not the push model, which means production in the production line will start only based upon the demand being raised from the end point, which means unless the consumer demands, the manufacturing process will not kickstart. So if there are 5 machines that would be required to manufacture a product to deliver it to the customer, once the customer raises a demand, machine 5 will raise a notification or a demand to machine 4, informing that I need to deliver 100 items of a particular jam bottle to my customer. In turn, machine 4 prepares itself to deliver the appropriate quantity to machine 5, meaning it will have to raise a demand on machine 3, which in turn will do it on machine 2, and so on and so forth till machine 1. So it is something which moves in the reverse direction. When you adopt this methodology, automatically we notice nothing will be produced in excess of what is required. Therefore, through one step itself, unnecessary piling up of inventory, obsolescence cost, inventory carrying cost, etc., defectives, everything will be brought down. Defectives, the workers will try to identify the defects on an instantaneous basis.